Hello, Math 150. We're going to be looking at the next section, or it's actually the first section in section 5.1, and it's all about learning how to measure angles. Now, you guys have all learned from long ago that angles are measured in degrees. Well, when we're talking about trigonometry, and that's what this chapter is about, we actually have a couple of different ways to measure angles. And I just want to introduce those to you tonight. Short lesson and then some homework associated with it from section 1. Your book is going to be mentioning something called the unit circle throughout this chapter. I'm going to teach this same material, but I'm going to avoid using the phrase unit circle. Although what you see on the screen right now is an example of what that unit circle might look like. It's when we take a circle and we put it on the XY axis, and that allows us to talk about angles that are as large as we want. A big portion of this section is going to be talking about triangles. When you think about triangles, you're limited because you can only have 180 degrees in a triangle if you add up the three angles of a triangle. We want to go bigger than 180. Because of that, we're going to introduce everything on a circle, and that's going to allow us to have more and more um, angles than just 0 to 180. So just to orient you guys, things to keep in mind as we're using this drawing, and we're going to be using this for the rest of the course. We're going to locate this spot right here, and we're going to call that 0 degrees. And now we're going to rotate around the circle in a counterclockwise manner. This makes sense on the quadrants because we call this quadrant 1. This is quadrant 2, quadrant 3, and then down here, quadrant 4. So if you remember how the quadrants are labeled, that's exactly how it goes. It goes in this counterclockwise direction. So starting here again, this is going to be 0 degrees. You guys will readily agree that this top will be 90 degrees. If we keep going, we'll get to 180 degrees over here. Then going straight down, we're going to go to 270 degrees. And then all the way back around is 360. What that means is we could continue to go around the circle again. This is just one revolution around the circle. If we kept going around again, this would actually be 90 more than 360. That would get you to 450. This would be 540. This would be 630, and then we go around again and get all the way to 720. So rotating in a counterclockwise manner, we can get angles as large as you want. Now, I'm going to throw this out at you right away. Rotating counterclockwise is a positive orientation. If we were to rotate this time negative, or I'm sorry, if we rotate in the clockwise direction, we're going to rotate this way. That's actually going in a negative direction. So if we were to label this going in that direction, this location would be negative 90 degrees. This location over here would be negative 180 degrees. Up here, we would get negative 270 degrees. And all the way around could be considered negative 360 degrees. So just like on a number line, positive means moving to the right and negative means moving to the left. On our circle, positive means rotating in a counterclockwise direction and negative means rotating in a clockwise direction. So this is the orientation you need to know about the circle and how this works. If I ask you to draw an angle of 45 degrees. That means you would start at 0 and you would rotate up 45 degrees. That would be halfway between 0 and 90. So what we would be looking at is we would be looking at an angle that goes right here, and that would be labeled as 45 degrees here. Or again, you could label it kind of on the circle as 45 degrees. It's the halfway point between 0 and 90. If I asked you to do a picture or draw an angle of, let's say, let's go down, let's get a fresh graph here. And this time, if I asked you to do an angle of, let's say, 120 degrees, okay, draw 120 degrees, what would we be talking about in this situation is we would want to start at 0 degrees. That would rotate up to 90 degrees up here. If we go to 180, we've gone too far. So we know we want to go 30 degrees past this 90, and that's where that 120 would be. So I would draw a line in this area, okay? But I would just know that this angle here is 30 degrees. But ironically, the more important angle that we're going to care about later on as this chapter goes is the leftover angle here, and that would be 60 degrees, okay? Either of these is labeled, we now know rotating from 0 to here, and again, I'm talking about going from here all the way to here. that would be our 120-degree angle. So just to look at one more to make sure we're on the same page, let's take a look at this one. Let's go down here and let's look at this situation. Let's say on this one now, I wanted to draw negative 210 degrees. Okay, if I want to draw negative 210, well, negative 210 means we're going to rotate in the clockwise direction. So that would be negative 90 degrees. That would be negative 180. This would be negative 270. So our negative 210 is going to go past 180 by 30 more degrees. So I would draw a ray or a segment like that. And again, starting all the way from here, this would be 210 degrees around the circle. But for our purposes, the way we would label that is we would write a negative 210 maybe at the end of it. That would show where its location is on the circle. But the one that you really want to do is the angle between the x-axis. And that actually is a 30-degree angle in there. And that is the one that we're really going to want to focus on. We're going to concentrate on drawing that angle that we make with the x-axis. Now, I told you before that there are going to be multiple ways we can measure angles. We've gone over how you measure it in degrees, okay? Counterclockwise, it's a positive. Clockwise, it's going to be a negative degree. And of course, the quadrants are all 90 degrees each. So we're going to see our 90, 180, 270, and 360 degrees labeled over and over again. Another way to measure angles is the idea of using radians. Now, radians, the idea is it's actually based on a distance around the circle. So if we were to talk about running around the circle, okay, let's talk about how far is it if we go around the circle. So if I started, right here, if I was standing right here, and I want to run all the way around the circle, how far of a distance would that be? Well, it all depends on how big the circle is. So let's simplify this. Let's start off by saying let's fix our radius to be equal to 1. Okay, our radius is 1. So again, that's why you heard me mention earlier, they like to talk about the unit circle. The unit circle just means a radius of 1. So if we remember our circumference formula, circumference is equal to 2 pi r. So if the radius is 1, the circumference is going to be 2 pi times 1. And that means that our circumference would be 2 pi. So that means the distance around the circle, would be equal to 2 pi. So let's imagine that the radius was measured as 1 mile. If I want to take and run all the way around this circle, to go all the way around, it would be 2 pi miles, okay? So imagine this. Imagine I go out and I'm like, okay, I'm going to try to make my way around the circle. I'm going to go for a little jog. I'm going to run. And what would happen is I would get to here, and all of a sudden I realize, I'm not in the best shape. Maybe I'm not going to make it all the way around. I'm starting to get a little tired. I'm going to push on and I'm going to get to here. But by the time I get here, that's it. I'm done. I can't go any further. That is the maximum amount that I can get around this circle. So now I need to go and I need to call for help. So how would I describe to someone where I was on this big circular path? Well, I could tell them, hey, I'm at 180 degrees. I'm at 180 degrees around the circle. But if someone was coming to pick me up, they might say something along the lines of, well, that's great, except for I'm not driving the protractor mobile. I'm not really sure how I would measure 180 degrees. I'm driving a car to come pick you up. So then I'd have to think about it. I'd be like, okay, cars, I need to give them a distance. Now I know the entire way around the circle is 2 pi. I've gone half of that. So what I could do is I could tell them when they started on the track and started driving the path to reset their odometer here and keep driving until they got to a distance of pi. So when their odometer showed about 3.14, or if they had a fancy odometer that actually used irrational numbers, when pi showed up on their odometer, they could stop the car. They would know I was right there. They could pick me up. So the idea is that we can think of a location on the circle as a distance. And in this case, that distance would be pi to get right here. Okay. So now maybe the next time I'm going out to try to make my way around the circle. Again, I come out the next day, I'm going to go for another run. I'm determined I'm going to try to make a full lap. This time I'm running. And by the time I get here, that's it. That's as far as I can make it. I'm beat. I'm worn out. I need to call and ask for help again. Well, same thing's going to happen. I'm now at 90 degrees. So I could say, hey, I'm 90 degrees around the circle, but the person who's going to come pick me up again wants a distance. So this is half the distance I had just done. So in this case, the distance would be pi over 2. Well, if you understand this kind of silly story that I'm telling, you're going to understand radians. You're going to understand radians really well because here's how it's going to work. Okay, here's what's going to happen. When we're talking about using radians, we are talking about just using distances around the circle. That's all we're talking about, just distances around the circle. So as I go to set this up, we want to think about where are you located on the circle? Well, looking at the circle again, just kind of starting over, let's relabel this. Let's use it as degrees first. We all understand our degree markers. 0 degrees is labeled, 90 degrees would be there, 180 degrees here, 270 here, and then 360 all the way around. But at the same time, we just got done saying that as long as the radius is 1, this is going to be a distance of pi over here. So I can call that pi. This would be a distance of pi over 2. Well, we're starting to develop a relationship between degrees and distances. And this relationship is built on the idea that a full rotation, 2 pi, is the same as going around 360 degrees. Okay. And that's when the radius is 1. But we're going to use that radius of 1 as kind of a standard. So we're going to just keep saying the radius is 1. So the full distance around is 2 pi. Once you lock that in, you now know halfway around the circle is 180 degrees. So halfway on distance has to be pi. This is kind of the key right here. If you can remember this fact, that pi and 180 are equivalent in this story, the rest is going to fall into place. Because we talked about the special angles and we did a little short video on showing you the special triangles. We are concerned with those angles, the 30, the 60, the 90, and the 45. So we want to talk about what would those distances be. Well, if 90 degrees is used, again, let's always compare to this one. 90 is half of 180, so the distance must be half of pi. It's going to have to be pi over 2. The next special angle we're going to want to talk about is 60 degrees. But again, compare this to the 180. 60 is 1/3 of 180. Since it's 1/3 of 180, that's going to get us to pi over 3, 1/3 of pi. The next one we want to look at is we want to do that 45-degree angle. So if we're talking about a 45-degree angle, 45 is 1/4 of 180. So if that's 1/4 of 180, we have to have 1/4 of pi. We're going to have pi over 4 for that result. And then the last special angle is 30 degrees. Well, 30 degrees, again, related to the 180. 30 is 1/6 of 180. So if it's 1/6 of 180, it's got to be 1/6 of pi. So 30 is going to be pi over 6. We are going to use these angles over and over again in this next chapter. You're going to want to really make sure you understand these angles. I am not a big fan of memorizing them. If you just remember that pi is 180 based on our story of distance around the circle, you can derive the others. By the time you're done your first homework assignment, you're going to use these angles so many times that you're going to probably memorize them, but you don't have to. Always relate to the 180, and that's how we can do this. Now, keep in mind, if I asked you now to draw an angle of pi over 3, draw pi over 3 on our circle. Well, you might think about this and have to think and translate, okay? Because we're still not fluent in this idea of distances. We think about degrees. So you might be like, pi is 180, pi divided by 3 is 180 divided by, that's my 60-degree angle. So if I go to draw that, I'm going to draw it somewhere in this neighborhood. To be honest with you, I still have the tendency to label this as 60 degrees, but I'm still going to put pi over 3 on the outside to show that's my pi over 3 angle, and that means it's a distance of pi over 3 around the circle as long as that radius is 1. Using the distances, we say we are measuring these angles in radians. Right? That's what we're measuring them in. On this side, we're measuring them in degrees, but on the other side, we're measuring it in radians. A lot of the unit we're going to be dealing with, almost all of the unit we're going to be dealing with, is going to want us to use radians. So until you get fluent, you're probably going to convert back and forth between degrees and radians, but every time we're going to stress thinking about it in radians, even if we start in degrees. One more idea here, if I ask you to draw negative pi over 4, the negative means the same thing. The negative means we're going to go in a clockwise direction. So if I go negative pi over 4, that angle would be somewhere in this quadrant, and I'd be down here, and this would be a 45-degree angle here, but this would be negative pi over 4 because I've gone in the clockwise direction. So again, this is kind of the idea right here. We're going to do a couple of examples of converting degrees to radians and radians to degrees, and then that will get you set up to try your first homework assignment. So let's go look at a couple of examples. What happens if we want to think about, you know, what if I tell you to do 5 pi over 6, and I want you to draw 5 pi over 6, or label it on the graph. Where does 5 pi over 6 go? Well, 5 pi over 6 is not easy the first time you do it, but you have to think of it the right way. Instead of saying 5 pi over 6, the way I like to think of this is I like to think of it as 5 pi over 6s. That's how I like to think of it, 5 pi over 6s, because I am going to remember that pi is 180, so a pi over 6 is a 30. So if I think of pi over 6 as a 30, this is really 5 degrees, 5 times 30 degrees. That's going to get me my 150 degrees. I now know this is going to be somewhere in quadrant 2. I'm going to draw this in quadrant 2. I'll label this as 5 pi over 6. On the inside, this angle here would be that 150 degrees I'm talking about. But again, we like to label in conjunction to the x-axis and the quadrant it's in. So really, I might just say 30-degree angle in there. But that is the line or the angle that's going to represent 5 pi over 6. I can do another one down here. Let's say I did 4 pi over 3. Let's do that one, 4 pi over 3. So we'd be thinking about that one. And again, don't think of it as 4 pi over 3. Think of it as 4 pi over 3s. Well, again, if you remember that pi is 180, a pi over 3 is a 60. So this is really going to be 4 60-degree angles, and that's going to get you 240 degrees. Well, 240, that's going to go past our 180 mark, and it's going to go into this quadrant down here, the third quadrant, and this is going to be 4 pi over 3. It is at 240 degrees, which means my angle with the x-axis is going to be 60 degrees in there. Okay, so that's going to be my 4 pi over 3 angle. What happens if they ask you to take a degree measure and change it into a radian measure? So let's say you had 150 degrees and you want to change it into a radian measure. Okay, well, the way I think about it is I use those special angles again. Which of my special angles goes into 150? Well, I'm not going to think of this as 150. I'm going to think of this as 5 30-degree angles. Okay, a 30 is a pi over 6. So I know that's going to be 5 pi over 6. That's where that's going to end up. Okay, I could then draw that in the right place. 5 pi over 6 goes right here and gets a 30-degree angle in there. All right. What if you asked me to do a 300-degree angle and change that to a radian? Well, 300 degrees, I'm thinking about this one and I'm like, oh, well, that's going to be 5 60-degree angles. That's what that one's going to be. So this is going to be 5 and a pi over 3, because a 60 is a pi over 3. So that will be 5 pi over 3. Again, 300 degrees going counterclockwise is going to put me somewhere in this quadrant around here. That would be 300 degrees or 5 pi over 6. Both labels are acceptable. The angle with the x-axis in that quadrant is 60 degrees. Okay, so some of these conversions you might want to get used to. Let's just look at a couple. Let's say, what if I want to do 120 degrees? What if I want to do 330 degrees? What if I wanted to do 135 degrees? What if I want to do 270 degrees? How would we convert these to radians? Well, remember, our angles are 30, 45, 60, and 90. Those are our special angles. We're trying to use those as much as possible. So if I think about 120, the biggest one I can use is the 60. I can say that's two 60s. Well, 60 is a pi over 3. So that's 2 pi over 3s, which would get me 2 pi over 3. So 120 degrees is the equivalent of 2 pi over 3. The next one I'm going to look at is this 330. Let me spread these out a little bit so we have some space. Okay, so if I'm doing 330, well, I'm thinking about using 30 for that one because that's 11/30s. But 30 is a pi over 6. So that would actually equal 11 pi over 6. So whenever you hear 11 pi over 6, it's really 330 degrees. They're the same angle. When I get to 135, kind of a dead giveaway here, it ends in 5. 45 is going to be our angle. So how many 45s is this? Well, this is 3 45s. But a 45 is pi over 4. So this will be 3 pi over 4, and that will be our angle. When we get to 270, which are the special angles can I use for 270? Well, my best one is 90. I'm going to use 90 in this one. So I'm always trying to use the biggest one of the special angles. So 270 is 3 times 90. Well, that's going to be 3 times 90 is half of 180, so it's going to be 3 times pi over 2. So that's 3 pi over 2. Now you might be saying to yourself, well, wait a minute, when I was doing 270, when I thought of 270, I didn't think of it as using 90s. I thought of it as using 30s. I thought of it as being 9/30s. That would be another way to think about it. That would still work. It can be an extra step, but it's going to work because a 30 is a pi over 6. So that's 9 pi over 6s, which becomes 9 pi over 6. But when you simplify this fraction, 9 has a factor of 3 in it, so there's 3 left over. When I take the 3 out of the 6, I've got 2 left over. That leaves me with that 3 pi over 2 we were talking about. So the idea is to use the biggest angle. If you use the biggest angle you can, you're not going to have to simplify it. So that's what you're after as far as that goes. The last thing I just want to go over with you really quickly is what happens if you're doing a problem and it's not one of these special angles. Okay, we can't use one of our special angles. Well, we have figured out that pi is the same as 180 degrees, which means when I write pi over 180 degrees, that is actually equal to 1. Now, it looks kind of funny, it looks kind of strange, but pi over 180 degrees is equal to 1. It's the exact same thing as saying 100 pennies over $1 is equal to 1 because the numerator and the denominator have the exact same value. As long as they have the exact same value, we're going to treat it as 1. Well, pi with no degree symbol over 180 degrees, that's the same thing. So the numerator is equal to the numerator, it's equal to 1. We now can use this as a conversion factor. So we can use pi over 180, or we can use 180 degrees, that's degrees, pi over 180 degrees, or 180 degrees over pi as a conversion factor. Let me show you what I mean by that. Let's go back to that example of 270 degrees. Okay. If I start in degrees, but I want to end in radians, I use this conversion right here. So what I'm going to do is I'm going to multiply this by 1. I'm going to multiply it by pi over 180. Now, multiplying it by 1 is not going to change the value. It's going to change the way it looks. So when I change the way this looks and I multiply across, I'm going to get 270 degrees over 180 degrees, and I'm going to have a pi. I like to write it afterwards. It can be written in the numerator. It's the same thing. But now we can simplify it. And when you do 270 out of 180, that's a 3/2 ratio. Take 90 degrees out of both. You're left with 3/2. That gives us 3 pi over 2. That's the same answer we found before, but we're using a conversion factor. So now if you're given one that you might not be able to use, like let's say, let's change 10 degrees into radians, okay? Well, the way you might think about this is the special angles can't really help you. 10 is smaller than all of them. Multiply it by the conversion factor for degrees to radians. Multiply it by pi over 180 degrees. What that will do for you is that will give you 10 degrees over 180 degrees, and then the pi on the outside. Well, the degrees cancel, and the 10 over 180, that's going to leave you with 1 over 18 pi. So that's really pi over 18, and that would be the same as 10 degrees, okay? So this pi over 180 converts from degrees to radians. So if you can't find the special angle fast enough, you can use the 30, the 60, the 45, or the 90. You can use this as a multiplication factor, and it will convert from degrees to radians. Likewise, 180 over pi converts from radians to degrees. So let's say you were dealing with something like, oh, I don't know, pi over 5. Okay. Now, again, personally, I think it's easier, faster, just stick 180 in for pi and do 180 divided by 5. But if you wanted to have a mechanical way to do this, you can use this conversion factor. So we're starting in radians, so we multiply this by 180 over pi. Okay, this is going to convert a radian answer to a degree answer. Notice what happens, the pi's cancel. Now I'm just going to write it like this, 180 over 5. Isn't that what we would have gotten if we just plugged in the 180 for pi right away? Okay, so it's the same thing. It's going to work the same way, just whatever you're more comfortable with. Now I'm going to do 180 divided by 5. 180 divided by 5, let's see, that's going to be 3. That's going to be 36 degrees. So pi over 5 is the same as 36 degrees. So for the homework on this section, what you're going to be asked to do is you're going to be asked to draw these angles where they belong, convert from radians to degrees or degrees to radians. Again, I'm just going to write this one more time. I really think the key to this is understanding 180 degrees is pi, and now using your special angles. 90 degrees is half of 180, it's half of pi. 60 degrees is 1/3 of 180, it's a pi over 3. 45 degrees is 1/4 of 180, it's a pi over 4. And then 30 degrees is a 1/6 of 180, so it's a pi over 6. If you learn these and learn these well, you'll be very happy because we're going to use these angles over and over again in this unit. Give section 1 a shot. Let me know if you have any questions. I'm there to help you out if you need anything. And have a great day, everyone, and look forward to hearing from you soon. Take care.